Myself, Jvn Dr Surendra Kumar from the Department of Science under the Faculty of Education and Methodology, Jyoti Vidyapeeth Women's University, Jaipur. Today, I will discuss the singularity. For better understanding of singularity, first we introduced by the zeros of a function. Let w is equal to fz be a complex valued function. If we put z is equal to a, then it is said to be 0 of fz if fa is equal to 0. An analytic function fz is said to have a 0 of order m if fz can be expressed in forms of z minus a to whole power m phi z. For example, fz is equal to z square minus 5z plus 6. That implies fz is equal to z minus 2 and z minus 3. So f of 2 is equal to 0 and f of 3 is equal to 0. Hence, 2, 3 are zeros of the function fz. For remark, fz is equal to z minus 2 to the whole of square and z minus 1 to the whole of cube. Then fz is equal to z to the power 4 plus 4 minus 4z and z cube minus 1 minus 3z square plus 3. Here z is equal to 2 and 1 are the zeros of the function. Now f dash z, here this can be written as f dash 2 and f dash 1 is equal to 0. It means f dash z is equal to z1 minus 2 and z minus 1 to the whole of square 3z minus 2 plus 2 z minus 1. Again this can be written as f dash z is equal to z minus 2 z minus 1 to the whole of square 5z minus 8. Again 5z square minus 8z minus 10z plus 16. This is z square plus 1 minus 2z. So 5z square minus 18z plus 16. This is z square plus 1 minus 2z. We notice here f dash z is equal to 5z to the power 4 minus 28z cube plus 57z square minus 50z plus 16. F double dash z is equal to 20z cube minus 84z square plus 114z minus 150, but here f double dash 1 is equal to 0 and f double dash 2 is not equal to 0, but f triple dash 1 is not equal to 0, whereas f triple dash 2 is equal to 0. In general, if z is equal to z naught is a 0 of a function fz of order n, then fz is equal to 0, f dash z is equal to 0, f triple dash is equal to 0, and f to the power n minus 1 z is equal to 0, but f of n z is not equal to 0. Now we understand the singularity. A singularity is of analytic function is the point at which the function ceases to be analytic. For example, consider a function fz is equal to 1 upon z minus a. This function is analytic except at the point at z is equal to a. So the point z is equal to a is the singularity of the function. For the remark, if fz is equal to plus minus infinity at z naught, then z naught is the singularity of fz. Now, types of singularity. First, removable discontinuity. Removable singularity. A point z is equal to z naught is a removable singularity of if Laurent expansion of fz about z is equal to z naught has no negative powers term. For example, consider a function fz is equal to sine of z minus a upon z minus a. So, fz is equal to 1 upon z minus a, and the series of sine z minus a means sine x, this is z minus a minus a to the whole cube upon factorial 3 plus 1 upon factorial 5 z minus a to the power 5 and so on. This is fz is equal to 1 minus z minus a to the whole of square upon factorial 3 plus z minus a to the whole power 4 upon factorial 5 and so on. In this case, we find that there is no terms containing negative terms of z minus a, that is the principal part of fz has no terms. So by the definition, it is a removable singularity at z is equal to a. In this case, we can remove the singularity by defining the function fz is equal to z minus a upon z minus a at z is equal to 1. For the pole, if the principal part contains finite number of terms, then singularity is called the pole. Consider a function fz is equal to sin z minus a whole upon z minus a to the power 4. Fz is equal to 1 upon z minus a to the power 4 in bracket z minus a to the whole cube upon factorial 3, z minus a to the whole power 5 upon factorial 5, and so on. Fz is equal to 1 upon z minus a to the whole cube minus 1 upon factorial 3 z minus a plus 1 upon factorial 5 z minus a. In this case, the principal part contains only the two terms. Then z is equal to a is a pole of order 2. Remark: if the principal part contains finite number of terms, say m, then the singularity is called a pole of order m. Now, the next singularity is essential singularity. If the principal part of fz contains an infinite number of terms, then the singularity is called the essential singularity. For example, fz is equal to e to the power 1 by z. Fx is equal to 1 plus 1 by z plus 1 upon factorial 2 1 by z square plus 1 by factorial 3 1 by z cube plus and so on. It is an infinite series containing negative powers of z, and such as z is equal to 0 is an essential singularity. Now the next isolated and non-isolated singularity. Let z is equal to a be the singularity of fz, and if there is no other singularity within a small circle surrounding the point z is equal to a, then this point is said to be isolated singularity of the function. If every neighborhood of a point contains other singularity of the function, then the point is said to be non-isolated singularity of the function fz. For example, fz is equal to z plus 2 upon z minus 2 and z minus 3. The function is analytic everywhere except z is equal to 2 and 3. These points are singularities of the function of fz, but there are no other singularities of the function fz in the neighborhood of their points, so these points are isolated singularity of the function. For example, fz is equal to 1 upon sin pi z. Fz is equal to so z is equal to z naught is a 0 of 1 upon fz of order m. Now we see the next theorem. The zeros of an isolated the zeros are isolated for continuous function. Let z is equal to z naught is a 0 of order m, then fz can be expressed fz is equal to z minus z naught to the power m phi of z. Since fz is continuous, then phi z will also be continuous, so there exists a neighborhood of z naught. This is z minus z naught to the power m. Phi of z is not equal to 0 except z is equal to z naught in the neighborhood of z naught. So z is equal to z naught is a single point of singularity, hence zeros are isolated. For the remark, poles are isolated. Let fz has a poles of order m at z naught. Fz is equal to phi z upon z minus z naught to the power m. So 1 upon fz is equal to z minus z naught to the power m into 1 upon psi z is equal to z minus z naught to the power m phi of z. Hence z is equal to z naught is the 0 of 1 upon fz of order m. Of the function fz is never of the function fz in neighborhood of these points, so these points are isolated singularities. For example, fz is equal to 1 upon sine pi z. This function is not analytic at the point z is equal to 1 by n. It has infinite number of singularities, hence this is non-isolated singularity. Thank you.